Hey guys, this is a continuation of last video. So we are still on trig 7.3 and pre-cal, this is 6.3. Still working with polar coordinates. We converted points at the end of last video. What we're going to do now is convert equations. Okay, this first step here is a suggestion to clean the algebra first. It can be solved without doing that. The question just gets a little messier. Okay, so I'm going to suggest that you clean the algebra first. And what I mean by that is we're going to see that in our second example here. If there's something to FOIL, I would say FOIL it first and then convert it, because if not, you're going to be foiling it with all of these sines and cosines in it, which will work. It'll just take longer. So if we're going from polar to rectangular, we're going to use these two formulas we learned about last class, and then we're going to isolate y. If we're going from rectangular to polar, we're going to use these two that we learned last class and then isolate r. So let's take a look at these. This first question says y equals 3x minus 2. So I'm going to start off by converting my y to r sine of theta equals, I have a 3, and then I'm going to convert my x to r cosine of theta minus 2. Now, you might remember in like an old algebra class, whenever you're trying to isolate a variable, which in this case is r, your teacher would tell you to get anything that has that r on one side of the equation and anything that does not on the opposite side. So what I'm going to do right now is I'm going to subtract this term to the left, so both of my r's are on the left. And then I'm going to leave that 2 over there by itself because it does not have an r on it. Now that every single term on the left side has an r in common, I can factor that r out. And then lastly, to get that r by itself, because it's being multiplied to this whole thing, I can just divide that entire thing over. And then I'm done. Everything is in terms of r's and thetas, and I have r by itself. Okay. So this next one is a little more complicated because there is that algebra to clean at the beginning. Let's take a look at it. Remember that whenever I have a squared there, it means that this entire binomial happens twice. So I have x minus 1 times x minus 1 that I'm going to have to FOIL. And then I have plus that y squared equals 1. So x times x, I have x squared. X times a negative 1 happens twice. And then negative 1 times negative 1. So now I'm just going to start rearranging things a little bit. I'm going to put my two squareds at the front. I'm going to combine these two negative x's, and I'm going to subtract this one from both sides. You'll see that'll end up canceling. So I have x squared plus y squared minus 2x equals 0. All right? So I've cleaned my algebra first. Now, before I move on, I want to show you a little something. These two equations, see that x squared and that y squared I kind of have right here? If I were to isolate that x squared plus y squared, I would have to get rid of this radical, which means I can square both sides, and I would have that r squared equals x squared plus y squared, which now allows me to change this entire thing to an r squared. And then I have this x, which I'm going to change into an r cosine of theta equals 0. Okay? Now notice that I have an r in common in both terms on the left side. So I can take an r out. When I take an r out, I still have one left here. This one I have none left, so I only had one. And now you might remember a rule from back in, let's say, Algebra 1. Here's just something, a quick reminder. Remember when you had something like x plus 2 times x minus 3 equals 0? and you would set each of them separately equal to 0? Well, the reason you were allowed to do that, to keep solving for x, is because they were separated by multiplication. All right? Oops, sorry. So here, because these two are separated by multiplication, I'm allowed to do this same thing where I can set each of them equal to 0. Now, this only works when it's separated by multiplication and when it's set equal to 0. So notice I already have this r isolated. Here's one answer. You see here how we would get two different answers. And then on this one, I would just have to move that 2 cosine over. And there's my last r isolated. All right. For these next two problems, we're going to be converting from polar form to rectangular. So we're going to still be using these formulas that I wrote up here. Let's look at this first one on the left. It says r equals 3. So if you take a look up here, we have a formula for r. Okay, so we're going to replace that r with the right side of this formula. So we can say, instead of r, I could say that the square root of x squared plus y squared equals 3. Okay. Now, we do want to isolate y. I will give you freedom to do something a little quicker if you can catch it. In order to get rid of that square root, we're going to have to square both sides. And now I have x squared plus y squared equals 9. Now, if you can recall back from either Algebra 2 or if you've taken a pre-calculus class or anything of the sort, that this is an equation of a circle, you are free to stop right here. Okay? If you wanted to continue getting y by itself, you could do so as well. You would subtract this x squared to the other side. So I would say y squared equals negative x squared plus 9. And then to isolate y, I'd have to square root both sides. Y equals, and remember that when I apply the square root, I also have to apply that plus or minus. So either of these are okay as your final answer. As somebody who teaches calculus, I'd like you to remember what a circle equation looks like. It's very helpful, and it makes your work a lot shorter. Okay? Now for this next question, I have theta equals pi over 6. Let's take a look back at our formulas for a moment. We have that theta is inverse tangent of y over x. So I can replace that entire theta on the left with this right side of the formula. Okay? So instead of theta, I could say inverse tangent of y over x equals pi over 6. Now, the inverse operation of an inverse tangent is just a regular tangent. If I apply a regular tangent to both sides, the inverse tangent and the regular tangent cancel out. Okay? So now I have y over x equals, and on my unit circle, tangent of pi over 6 is 1 over radical 3. Okay? If you don't remember how to do that, let's make a quick little side note. Okay. At pi over 6, my ordered pair is radical 3 over 2, comma 1/2. And then remember that tangent is sine divided by cosine, so I'd say half divided by radical 3 over 2. And then I'm going to multiply by the reciprocal, or we have that saying keep, change, flip. My 2's cancel, and that's how I obtained the 1 over radical 3. Okay? In my pre-calc classes, I suggest that you memorize your at least your main 3 tangents. Okay? Now, last step here to get y by itself is to multiply the x over. So I have y equals 1 over square root of 3x. And I'm done with this one. All right, I have these last two questions for you here. I would consider these a little trickier just because they're not as upfront in which formula you need to use. So if I look at the first one on the left, we are going from polar to rectangular. I do have a formula for r, but I don't have a formula for simply cosine of theta. If you look back at your formulas, the only one I have with a cosine of theta is an r times cosine of theta. So like back in algebra, when we were trying to solve an equation that we were allowed to like add a 3 to one side as long as we did it to the other to keep it balanced, that same rule is going to apply here. So if I have a formula for cosine with an r being multiplied, that just means I can multiply an r in, but if I do it to one side, I have to do it to both. Okay, so now here I'd have r squared equals negative 2r cosine of theta. And now I have something that I can use from my formula sheet. So feel free to manipulate your problems as long as you do so to each side. So I know that r squared is x squared plus y squared. And then I'd have negative 2, and r cosine is an x. Okay, so let's work on getting that y squared by itself. And then to get rid of that squared, I'm going to square root. Remember, every time you apply a square root, you have to apply that plus or minus. And we are done with this one. Now, for the question on the right, I have r equals 5 cosecant of theta. Now, cosecant is not one of my rules, but I have learned in the past a different way to write cosecant. I've learned that cosecant is the flip-flop, the reciprocal of sine. Okay, so I can start off by rewriting this as r equals 5 times 1 over sine of theta. Okay, which if you want to rewrite it a little neater, we can say 5 over sine of theta. Now, in my formulas, I have one that has sine being multiplied to r, which is conveniently going to work for me because this sine is currently being divided. So if I want to apply the inverse operation, I just multiply the sine to both sides. These two cancel. And now on the left side, I have what I need for my formula. I have r sine of theta equals 5, and then I can conveniently change my r sine into a y. And I'm done with this problem. R's and thetas are gone, and I isolated y.